So this is a very nice question. That if the divergence of B is not equal to zero, but suppose it is equal to some mu naught rho m, where rho m is magnetic charge density, but nothing exists like this. But suppose it is the case, and suppose Jm is the magnetic current density. So how the Faraday's law del cross E will be modified? So that is the question. Okay. Now what I have to see, why this symmetry they have written, because del dot E is rho by epsilon naught. So seeing this, if magnetic charge would exist, epsilon naught will be replaced by 1 by mu naught. So that's why mu naught here, and rho, which is charge density, will be replaced by magnetic charge density. Okay. So that's why they have given it that del dot B is something like this. Now we have to modify the Faraday's law. What is the Faraday's law? Generally, it is del cross E is equal to minus del B by del T. Okay, this is the Faraday's law in normal sense. And when I take divergence of this quantity, it becomes here divergence of B. And in normal case, divergence of B is 0. So it satisfies that divergence of curl is always 0. Okay. It satisfies this equation that divergence of curl is 0. But this is not the case here. Here, what is happening that if you take del, then this quantity mu naught rho m will appear, and so that this divergence of B will not be equal to 0. So that means I have to just modify the Faraday's law. So what I am going to do is, I will write it like this: del cross E is equal to minus del B by del T, and plus, let me write something like some uh, vector x, and it will make sure that divergence of curl always becomes 0, because that is a mathematical compulsion. We can't do anything about it. So now if I take divergence of curl, it will become minus del divergence of B by del T and plus divergence of x. Okay. Now divergence of B is given to be, and this should be 0. That is mathematically. And this is equal to minus del by del T of, what is del dot B? It is given to be mu naught rho m plus del dot x is equal to 0. And this is uh, del dot x is equal to mu naught del rho m by del T. Okay. So by continuity equation, if something of this sort will exist, we apply generally continuity equation for charge, but let us apply it for magnetic charge in the same way, because if this will exist, there will be Jm also. So continuity equation says that del dot Jm will be equal to minus del rho m by del T. Okay. So that means I can replace this by mu naught minus of, so let me put minus here, minus of del dot Jm, okay, is equal to del dot x. So now what is the vector x? Clearly you can see from here that x is equal to minus of mu naught and Jm. So now our equation is modified, the Faraday's law is modified, x is equal to minus mu naught Jm. Okay, so just straightforward doing the simple mathematical approach, simple mathematical concepts, and of course your Maxwell's equation got modified by this. Okay, thank you so much.